I heartily welcome you all to Math Simplified by HM. A very warm welcome to everyone joining us. To support the channel, please like, share this video with your friends and colleagues and hit subscribe and the bell icon for regular updates. Now, let us get back to our geometry series. We have already mastered the basics. A tangent hits a circle at one point and stays perpendicular to the radius. Today we take it a step further. If a point is located entirely outside the circle, how many tangents can be originate from it? Grab your notebook, pause as needed, and let us dive into the proof. The geometry of tangents, proving the exact number of tangents from an external point to a circle. The premise, we are given two simple entities, a circle with a defined center O, circle with a defined center O, a point P floating freely in the space outside the circle. Can we connect point P to the circle using a tangent? Let us see. The core constraint, a tangent is a line that intersects circle at exactly one point, the point of contact. The tangent theorem, a tangent is always perfectly perpendicular to the radius at the point of contact. We know the tangent theorem, a tangent is always perfectly perpendicular to the radius at the point of contact. See in the diagram. This is a circle, this is a radius, and this is a tangent, and as per tangent theorem, this radius is always exactly perpendicular to the tangent. The scenario matrix, the point inside the circle, we have given point outside the circle, but what if point is inside the circle? Every line drawn through the point intersects the circle twice. Therefore, result is 0 tangents and all are secants. Point on circle. Only one line can be perpendicular to the radius at that exact spot. Therefore, result is 1 tangent. Point outside the circle. The lines skirt the edges of the circle. Result, how many tangents? We will discuss and find it. Setup for construction. To find the exact number of tangents from external point P, we must rely on geometric construction, not visual approximation. Step 1. Connect the external point P to the center of the circle O. The geometric key, how do we guarantee a 90-degree angle out of a thin air? The semicircle rule. Any angle inscribed in a semicircle anchored by the diameter is always exactly the 90 degree. We are going to use this property. Now preparing the anchor. To utilize the semicircle rule, we must treat our connecting line OP as the diameter. Step 2. Find the exact midpoint of segment OP. Here we have taken M as the midpoint of segment OP. Constructive breakthrough. Using M as the center and OM as the radius, we construct a new circle. The limit of intersection. A fundamental law of geometry states that two distinct circles can intersect at maximum of exactly 2 points. Let us label these 2 points of intersection as A and B. Inevitable right angles. Connect points A and B both to the center O and external point P. Because A and B sit on the orange circle with diameter OP, angles OAP and angle OBP are angles inscribed in the semicircle. Therefore, They are perfectly 90 degree. The synthesis: a tangent requires a 90-degree angle with the radius. A 90-degree angle requires the point 2 lie on the constructed semicircle. The point must also lie on the orange circle. Because two circles can only intersect exactly twice, there can only be exactly two 90-degree angles, thus exactly two tangents. Thanks everyone for excellent focus today. As you practice, remember that geometry is all about finding these hidden logical intersections. Keep looking for those connections. Please like, share this video with your friends and well-wishers. Subscribe to the channel and click the bell icon to stay updated with all our latest tutorials. Enjoy the great time, and I look forward to seeing you in our next session.